Hello, I'm Mike McCormack of AIQ. This video clip gives an overview of the power supply technology that AIQ has developed for the L01 line sensor, which is a key component of the L700 and M700 systems. The L01 is the edge data gathering device that feeds the master software's multiple algorithms with the precise data needed to capture the locations of faults that occur in the network. It is critical, therefore, that its power supply is as close to uninterruptible as possible and maintains a 24/7 presence. Just a recap of AIQ, it is the outcome of a collaboration between leading engineers in the European power industry, and the INSIGHT range of products and software is the result of this collaboration. So when AIQ's engineers were tasked to design the line sensor, they started by engaging with customers to get their requirements, which were reliability, accuracy, and simplicity. This included a line sensor that was always on as much as possible. The team sat down and looked at the always on requirement and then at the available technologies that are used by this type of device, which were primarily H-field harvesting. This technology is well proven and has been in use for decades. Some of the sensor devices in the market also have a rechargeable battery backup, but all are subject to having a minimum of load flowing in the line to operate. When this line load falls below this minimum value, the device is reliant on the charged battery to provide power until it runs flat. This is a significant downside to an otherwise very good technology. In some of these sensors, this minimum line load is as high as 12 to 15 amps, depending on the computing and communications complexity of the device. And this means that sensors that use H-field harvesting with battery backup are practically certain to run out of power from time to time, and are therefore not a reliable source of line data. In some cases, super caps are used, which may be used for last gasp. These are also very good, but they are reliant on strong communication platforms, as the possibility of multiple communication attempts are not ideal for this technology. After careful consideration, the team determined that the H-field harvesting was good, and they produced a powering technique that produced sufficient power from the line when as little as 3 amps of line load is flowing. But the team also determined that it needed additional powering support, and for this they chose a solar panel incorporated in the sensor to deliver this extra power. The team then set about integrating 3 sources of power: H-field, solar, and battery. This integration process was defined, developed, and tested, and is the optimal power supply for the INSIGHT L01 line sensor. In addition to increasing the power available, the engineering team also considered the demand side and designed in techniques to reduce the power required by the sensor. This development included selecting the latest technologies for radio communications, including duty cycle, bandwidth, and power, and designing in efficient data processing. This technology development has produced a power supply that is efficient, practical, and reliable. And when this technology is coupled with the sensor's advanced current measurement techniques, particularly with respect to faults and transients, you have a sensor that is lightweight, compact, simple to install, and meets the needs of the network operator. Thank you very much for visiting our website, and if any of the AIQ team can help you with any questions that you may have, please do not hesitate to contact us.